Good morning. Welcome to
Math for Kids number 104. Special morning video.
Special morning video because we're a little busy tonight. Okay. Bonk. All right. So today we're going to talk about hexadecimal subtraction. Okay. So do you remember what hexadecimal is about?
Yeah, it's base 16.
It's base 16. Okay. So in base 16 we have, if you watch, I guess I should back up. This is going to be the last in our series about binary and hexadecimal, and we're going to move on to do some other stuff. So this is like the 6th or 7th video in a row. So if you're just watching this one for the first time, it may be helpful to go back a little bit to when we started talking about binary. But in hexadecimal, you have a funny problem that you don't have in binary or in base 10. What is it?
It's that there's only 10 digits.
There's only 10 digits, so we need a little chart. The digits A, B, C, D, E, and F represent 10, 11, 12, 13, 14, and 15. Okay?
Yep.
So we're going to take a look at subtraction, and subtraction works, just back up just a little bit. So the subtraction works exactly the same way as it does in binary and in decimal. And if you think about what we did for our adding yesterday, it kind of works the same way as that. So we're going to look at an example of, well, let's do 3e4 base 16. So first of all, just for practice, what is this number?
Well, this is the ones place.
That's the ones place.
This is the 16s.
This is the 16s place.
256.
Okay. So this number is equal to?
It's 3 times 256.
3 times 256.
Plus e times 13, which is 14 plus 14 times 16.
Right, plus 14 times 16.
Plus 4.
Plus 4. Okay, so we have to figure this out. Now 3 times 256. So we got 3 times 256, e times 16, and 4 times 1. Actually, right, 4 times 1, just to be clear up there.
So this is 768.
768, are you sure?
Yeah.
How do you know?
This is 600 plus 150, which is 750 plus 18.
Oh, okay, good. 768. Now what's 14 times 16? Can you back up just a little?
14 times 16. It's 224.
224, okay, and that's because it's 160 plus 64?
Yep.
224. Okay, now go slow on this one. 4 times 1.
4.
4. Okay, so we got 768 plus 224 plus 4, which is 900 plus 80 plus 16, right?
Yeah.
So that is?
It's 996.
996. Can you find me an eraser? Okay, so 3e4, which is 996, and sorry, I'm going to have to erase all this stuff that we just did up here. 3e4 happens to be 996. Okay, that was just some good practice. And now we'll do a subtraction. Minus 29f, base 16.
Do it minus 295.
29f, and let me just get a little drink of coffee. 29f. Now quickly we got to figure out what 29f is. I'm sinking on my little yoga ball here. Alright, 29f is 2 times 256 plus 9 times 16, and what is f?
F is 15 times 1.
Okay, so 2 times 256 is
512.
9 times 16 is
144.
144. 1 times f is
15.
15. Okay, so this is 600 plus 60 plus 11. Is that right? 671. Okay, so if we're going to subtract these numbers, we better get a hexadecimal number that equals what?
That equals this subtracted.
Which is?
325.
Okay, so we're hoping we find a hexadecimal number that equals 325. Okay? Now, let's just go ahead and do it. 4 minus f.
Is 4 minus 15, which is, it's negative it's negative b.
Alright.
Or negative 11.
Let's just call it negative 11 for now. E minus 9.
Is 14. 14 minus 9 is 5.
Okay.
And 3 minus 2 is 1.
Okay. So we get the hexadecimal number 1, 5, minus 11, base 16. Now, does that look right?
No.
No. But let's just see if it is right, by the way.
Yeah.
Okay. This is the same as 256. 1 times 256 plus 5 times 16, which is?
Which is 80.
80. And then minus 11. So let's just do this as 336.
Yeah.
Minus 11, which is?
325.
325.
Wood.
Okay, so our silly hexadecimal number, 1, 5, minus 11, base 16, does in fact equal 325. It's just that we don't like to write hexadecimal numbers with minus 11 as a digit, because that's very confusing.
Well, it's less than 16, so you can't move it over. Maybe you can.
So we need to make this a positive number. All of our digits in a hexadecimal number need to be positive. So we have 1 times 256 plus 5 times 16 plus minus 11 times 1. Okay? Where can we find something to bring over here and make this minus 11 positive?
Well, we need another negative number to make it positive.
Another negative number?
A negative times a negative is a positive.
Well, we're not going to multiply.
Oh yeah, we're going to subtract.
What are we going to do? Do you remember what we did when we subtracted with the binary blocks?
Yeah.
And we had a red block here. So go back a few videos. We had a red block, and we needed to get rid of it. What did we do?
Well, what we did is, it was a minus 1. We had to make it a positive number.
How did you make it a positive?
You had to get it to a yellow block, which is a 1. How did we do it?
How did we do it? Okay. We took a block from over here and brought it over here. Okay? So what we're going to do the same thing here. 1 times 256. I guess this won't be our last video. We'll do one more tomorrow to make sure you understand this, okay? Plus 4 times 16. I'm just going to take a 16 from here, and where am I going to put it?
I'm going to put it with this minus 11.
Okay, plus 16 times 1 minus 11 times 1. So I also, something that's not allowed over here is a 16. I have a minus 11. That's bad. We don't like minus 11s.
Yeah.
So what I do is I bring a 16 from over here and group it with here. And what do I get? 16 times 1 minus 11 times 1 is?
Is 5.
Right, so I get 1 times 256 plus 4 times 16 plus 5 times 1, which is the hexadecimal number 145. Right?
Yeah.
Okay. Now let's just see if 145 equals 325. It's 256
Plus 64.
plus 4 times 16, which is 64, plus
5.
5. So that's 200 plus 110 plus 15,
Yay, 325.
which is 325. Okay?
Yep.
All right. So that same thing we did with the Duplo blocks, where we moved one over.
Yeah, we moved one over to get a positive number.
To get a positive number is what we're going to do here. So we'll do one more tomorrow to practice subtraction, okay?
Okay.
All right. Good job, sweetie. High five. High five. High five.
Awesome.